Hi there. So we've been doing our integer unit, and today we're going to talk a little bit about exponents. But before we can talk about integer exponents, we have to talk about regular exponents that we're already used to. So I wanted to do a quick little exponent review. For example, anytime you have a number that has a tiny little number above it to the right, it's called a base and an exponent. So in this case, we can see 4 to the power of 2. The base is 4, the exponent is 2, which actually means repeated multiplication. 4 to the power of 2 is equal to 4 times 4, which is equal to 16. Now this has an exponent of a positive integer. Even though you don't explicitly see the plus sign, we can assume that the base and the exponent are both positive integers. Same with 3 to the power of 3. It's 3 times 3 times 3, which equals 27, or 5 to the power of 4, which is 5 times 5 times 5 times 5, which equals 625. And please don't forget as well that BEDMAS is constantly applying, and where the exponent is will tell you what to apply the exponent to. For example, in this expression down here, 5 times 4 plus 3 to the power of 2, obviously, you would do the exponent first because there are no brackets, so it would be 3 to the power of 2 first, which is 9. You would then go on to solve 5 times 4, which would be 20. 20 plus 9 equals 29. But this expression is a little bit different. 5 times bracket 4 plus 3 to the power of 2. Now, because the exponent is outside of the bracket, that means the exponent is applied to everything within the bracket. So it would be 5 times 4 plus 3 to the power of 2. 4 plus 3 bracket first is 7 to the power of 2 is 49. So now we have 5 times 49. I don't have my calculator with me. You can figure out the answer. But what happens when the base or the exponent are negative? Okay, so now we get to talk about negative exponents. Let's start with the most easiest. Let's start with having a negative base. So in this example, I can see negative 2 to the power of 3 is equal to negative 2 times negative 2 times negative 2. And you guys should know how to do that because the other day we learned about how do we multiply exponents. And we know that a negative times a negative equals a positive, and then times a negative again will equal a negative. So we've got 2 to the power of negative 2 to the power of 3 is actually equal to negative 8. But it's important to remember that you have to do all of your multiplication in steps. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. On the flip side, negative 6 to the power of positive 2 is negative 6 times negative 6. So you know you're going to have a positive answer, which is going to be positive 36. By this, you should also know that there is a pattern. Any negative exponent to the power of an even exponent is going to end up with a positive integer outcome. Any negative base to an odd number exponent will give you a negative outcome. But what happens when the exponent itself is negative? Okay, so negative exponents but positive bases. Here's where, as far as we're going to go today. You know that when we have a regular power, like say 3 to the power of positive 2, we have 3 times 3. We know that it is repeated multiplication, but what's the opposite of multiplication? It is division. And therefore, when we have 3 to the power of negative 2, we actually have to do division. Now, the easiest way to do this is turn it into a fraction, which means that 1 over 3 to the power of positive 2 will give you your answer. So in this case, it would actually equal 1 over 9. 3 to the power of negative 2 is 1 over 9. That's because what you're doing is essentially flipping the reciprocal. So if you remember when we had fractions and we had to divide fractions, in order to divide fractions, we had to flip the reciprocal and multiply. Well, any number can be turned into a fraction. So 3 to the power of negative 2 is actually 3 to the power of negative 2 over 1. So what we do is we flip the reciprocal and then we make it positive for 1 over 3 to the power of 2, which equals 1 over 9. In this case, it's 4 to the power of negative 3. We then put 1 over 4 to the power of positive 3. We do 4 to the power of 3, which is 4 times 4 is 16, times 4 is 64. So our answer is 1 over 64. In this case, we have 5 over negative 3. Again, I could put it to you like this and say, okay, it's really 5 to the power of negative 3 over 1, but I don't have to do that because I know it's just 5 to the power of negative 3. But so that you can see me flip the reciprocal, I can go this equals 1 over 5 to the power of positive 3. So when we do that flipping, we're changing the negative into a positive power, which means this actually equals 1 over 5 to the power of 3. 5 times 5 is 25, times 5 is 125, which equals 121 over 125. And you can say to me, okay, well, Mrs. Thompson, does it always have to be in fraction form? No, it doesn't always have to be in fraction form. For example, you could take a look at this and you could say, okay, I think, Mrs. Thompson, that this would be much easier outside of fractions. If that's the case, you have to start off with the number 1 and divide it by 3 twice because you are repeatedly dividing. 1 divided by 3, then divided by 3 again, and you will get your 0.0 answer. And that will allow you to get a decimal answer as opposed to a fraction answer. Either way you choose to do it is completely and totally acceptable. By the time you get to high school, you might be dealing more along the lines of this, but I know that in grade 9 and 10, this is completely and totally acceptable. Okay, so that is dealing with negative exponents. So today you're going to be practicing with exponents. I'm going to give you negative bases. I'm going to give you negative exponents. I'm going to give you positive bases, positive exponents. And I want you guys to see if you can figure it out. Good luck today.